before 2022, you had to assemble training data, which was very difficult. This training data wasn't readily available. It was difficult to assemble almost in all cases. So let's say you wanted a named entity recognition to recognize name of diseases in text. So you're in a pharma company, you want to recognize the name of diseases that are written in published articles. You had to find training data with the names of those diseases. You had to find enough training data that's in sufficient quantity, and that's in sufficient diversity so that it covers all the cases that you want. So that was the first part. Then you had to prepare this data. You had to coerce this data and arrange this data in a way that was useful for a model, for an algorithm, so you could train it. This took months and months and months and months. Anyone who's been in that world for years before will recognize that it wasn't easy. So you would spend months and months finding this data, preparing this data, and then you would train a classifier or you would train an NER in order to do what you were trying to do. So maybe after 6 months, 9 months, maybe you had an NER, or maybe you had a text classifier, or maybe you had a topic modeler. That was okay. And it wasn't fantastic, but it was working. And then you would improve it, you would improve the data, and so on. So it could take you 9 months, 10 months to do this kind of work, to produce these machine learning models. In my previous job, that's what we used to do for 5 years. It was extremely difficult. It was difficult work. It was demanding. It took a lot of time. Now, the first thing that happened in business, when you think of business reality, and most businesses did that, the first thing that happened is that all of a sudden, we had an algorithm, these large language models, that would do all of these things out of the box. Not perfectly well, but if you wanted an NER, you just ask. Here's my test, tell me which diseases are in this text. You want a text classification? Classify this text, which is what is positive, what is negative. Classify these comments. Out of the box, it would do it. Topic identification, it would do it out of the box. Sentiment analysis, all these things. So all these NLP tasks that were painstaking, difficult to build, all of a sudden they were just out of the box from a model. Weren't perfect, but you would get that. So that was the first extremely interesting use case where we started using it instead of recreating all these models and spending all this time with the data preparation and so on. The fantastic thing about LLMs is that they came with bonus capabilities that really changed everything. The bonus capability was that you could teach these models, you could teach these large language models right inside the context. You don't need fine-tuning. For most tasks, 90% of the tasks in business, you don't actually need to fine-tune anything. You just explain right in the context what you want, and then it's able to do it. So think about that for a second. If you've spent 9 months collecting data, preparing this data, training a classifier, and this classifier is trained to recognize when an article is about cancer, let's say when it's about oncology, and when an article is about dermatology. Once the model is trained, you can't just say, oh, now I want you to know if the article is about cancers or is about diseases of the skin of a different variation. Whatever it was trained on, that's what it is. If you want something else, you have to train it again. You have to assemble the data and so on. So now, large language models, they brought this incredible new capability where you can teach it right inside the context. That's amazing. So if you want to classify something new, you just explain it in the context. You provide examples and so on, the zero-shot, few shots that we are all familiar with. Now, that wasn't the end of it. On top of that, you had the ability to follow instructions. You could tell it to do certain things and it would follow those instructions. And it had something that looks like reasoning. Is it real reasoning? Is it not real reasoning? From all particle perspective, it's more philosophical questions. What matters is that it looks like reasoning. Okay, is it really reasoning? Doesn't matter. It looks like reasoning. It behaves like reasoning. So these bonus capabilities were sort of at the end of 2022, at the beginning of 2023. And this is really the beginning of the most important use cases in business today. What these capabilities allowed is for businesses, and this is what we were doing at that time in the beginning of 2023, to think, wait a minute, this is not just to do some simple LLP tasks. I can actually perform human-like tasks. I can perform work that is cognitive work that requires cognition, that you would normally ask a human to do. Very common use cases that we had where a lot of large documents, companies have large documents, big documents with lots of text. And a lot of these documents, you would need people to read them, to go through the information, to take notes, and to sort of pull out structured information out of these documents. Many companies have these use cases. Now you could automate those things using GenAI. So you could translate complex technical or structured information like code into human readable explanations. You have lots of code that's undocumented, you can document it now. You could read and interpret complex instructions, logic, and explain the underlying intent. What are we trying to do in this particular context? So lots of people were using that to migrate off of legacy systems. You have lots of legacy systems, lots of legacy code. You can use that to speed up the work of this conversion. You can also review long-form content and identify key ideas, key themes, key insights. There's a lot of people employed to do that. For example, in investors' relations, people have to go through long transcripts of investors' relation calls and figure out what did they say about this topic, what did they say about this other topic. So extracting these key ideas, and also normalizing, organizing, and structuring unstructured information into consistent formats. So parsing data out of document. So there were a lot of use cases where it's a task that normally would require a human to do it. It would take a really long time. We have use cases, for example, where a task takes, I have use cases personally, where a task would take 40 hours to do, and leveraging this technology, we can do it in an hour. So really human-like tasks that are sort of like cognitive tasks that require following instructions, doing something that resembles reasoning, and pulling out the information. So in beginning of 2023, we started strong on these use cases. We started pushing on these use cases, but we were still at an experimentation phase. So you can imagine in your own organization, in your company, where you are. Are you at the NLP tasks? Are you just using it to do basic extractions, basic parsing? Have you started looking at human-like tasks like, okay, we have this big document that comes in every month we have to read. Maybe we can automate part of that. So in order to do those tasks, the first place where everybody started we certainly started there in the beginning of 2023, is, okay, this is a model, it's an LLM, we're going to prompt it, we're going to ask it what we want to do, and it's going to output the result. So we'll send the text and we'll say, I want the key points, and it's going to give us the key points, and it's going to make our life easier, it's going to make our life faster. Right away, everyone adopted the RAG pattern, because quickly you notice that you can't put everything in the prompt. So in terms of lessons learned, you cannot put everything in the prompt. There is a limitation to the prompt. There is a physical limitation to the prompt. At the time, there was quite a hard physical limitation to the prompt. It wasn't that big. So since you can't put everything in the prompt, you have to retrieve and you have to add only what's relevant to each transaction. And this is where RAG initially came from. If I want to send different documents to the LLM to ask for some extraction, I need to explain, I need to add some clear instructions, okay? I cannot add the instructions for every type of document I'm going to send. So when I send document A, I'm going to add the instructions of document A. When I send document B, I'm going to add the instructions of document B. So I keep all the instructions in a vector database, or just any database is fine if it's not a semantic search. And the idea is that at the moment of prompting, I'm going to retrieve the information that is going to help the LLM, and I'm going to add it inside the context. And it's going to help the LLM do a better job. So that's the base pattern. This pattern is sort of like ground zero. It's the first base pattern that essentially everyone used. Now this pattern works fine, but you will quickly notice that there's some limitations. You're going to hit limitations when you're using this pattern. As I was saying, the first limitation is there's a limitation to the number of tokens you can put in your context and send to the model. Since then, the context window has increased substantially. I saw recently Opus 4.6, now it's at 1 million tokens. So it's gotten a lot bigger than it was. The first limitation was that there is a limit to the tokens you can put. So there's so much you can ask because of that physical limit. In reality, when you start using these things and you start experimenting with these things in a real business context, you're going to notice that the token limit is really the least of your worries. Even if the LLM has a token limit of, let's say, 250,000 tokens, in reality, past 10,000 tokens, 15,000 tokens, and past 3-4 steps of process that you're asking the LLM, performance drops dramatically. Performance drops sharply. The accuracy drops like a rock. Latency goes through the roof. So in-context learning really has its limits. And it's not the token window that's the limit. It's really that the model does not have the capacity to handle that much information. There's been a lot of tests about that. I've experienced it firsthand many, many times. Past a certain size of a text, past a certain number of steps that you're asking, it starts failing. It doesn't work anymore. The placement of instructions, the placement of information in the context matters. It starts forgetting things that are in the middle. It starts forgetting things that are placed in between the top and halfway. The number of steps. If you want the model to do A, B, C, D, after A, B, C, it starts forgetting D, it starts forgetting E, it starts dropping instruction. And also, the model doesn't know what it knows. What I mean by that is, you've probably experienced it. You ask something to an LLM, it gives you the wrong answer. And you say, no, this is the wrong answer. And then it says, oh yeah, you're right, it's the wrong answer. I know the answer, it's this. So the information you were looking for, the information you were asking, is there. It's in its training data. It's part of its training data. It's part of its knowledge, if you will. But when you ask a certain question and it goes on a certain tangent, it focuses on certain areas of its semantic space and it forgets completely about other areas. So the way I describe it is that it doesn't know what it knows. It's not like a person who's going to think, oh, yeah, but what about this? No, you do a single prompt, it might very well forget many things that are present in the training data, or that are absolutely there. So what you learn from that is that splitting the task over multiple prompts increases quality significantly. This is the beginning of agentic AI. This is how agentic AI started. In about beginning of January 2023, mid 2023, the term wasn't coined yet. People were not calling it agentic AI yet, but people working in that field, people working in engineering, they saw this problem. And they saw that I have use cases where we have a single prompt in a chatbot, and we ask a question to that prompt. And we split the same prompt in two, and we ask the same question. You should see the result. It's shocking. It's night and day. Same model, same request. The request in one go versus the request in split in two, where you have the first prompt, which is a reviewer, where you ask in the first prompt to review the request and make a plan. So call it the reviewer or the planner. And the second step, which is the execution, the executor. Just by splitting in two, the same request, performance and quality goes through the roof. It's like night and day. The first one is extremely bad, and the second one is extremely, extremely good. So splitting the task over multiple prompts increased quality dramatically. So there's several ways to do that. The first way that I've tried, and the first way that many people tried, is a single agent with tools. The most known pattern of this is called React. You can read about it. There's a paper that was published around that time, a little bit before that time, that described the idea. The idea is that you have one LLM, but around that LLM, you're going to create a loop using usually Python, and you're going to tell that LLM, we're going to do this job, and this job has 10 steps. You're going to do step one, and each step you're going to do an action, and you're going to get an observation, and then you'll decide on the next step. So you send the first prompt. It decides, oh, I need to fetch this information. It fetches, it's not the model that fetches it. It's the Python that fetches it, by the way. The Python fetches whatever needs to be fetched, puts it as an observation, and prompts the model again. Now the model knows, oh, I've done step one. This is the observation that I got. An example that I had was a React loop to calculate the travel distance. You can ask, how long does it take to go from Montreal to New York and then to Boston? You send that as a prompt, as you send that as a user request, sorry. The LLM is told, your job is to figure out how long it takes from any 2 points. In order to do that, you're going to first start by finding the travel distance between each leg. And once you have the travel distance between each leg, you're going to add it up and you're going to find the total travel time. So first step it's going to do is going to say, oh, I need to find the travel distance between Montreal and New York. So it's going to ask a tool to find that travel distance. The Python will fetch data and will send it back. And now it will know. Now I have the first leg of the travel. Let me find the travel distance of the second leg. It's going to go back, it's going to find it, it's going to do that. So this is basically the beginning of agentic AI. This is the simplest agentic unit. If you look at all the agentic frameworks today, the majority of agentic frameworks today, what is called an agent is this. This is exactly what an agent is. If you use LangGraph, LangChain, Crew AI, all these frameworks, this is what is an agent. To avoid the confusion, there's a lot of confusion with the executives and people are not in engineering and so on. It's not a new technology. Agentic AI is not something new. It's a design pattern. It's the same LLM as before. It's just this LLM is used inside a loop where we add Python programming around it in order to do tool use, send it back the result, in order to do memory, and in order to do all these things. So what's really important to realize is it's not something, the models are not new. It's the same models used in a different manner, in a different design. So this is a single agent. So how does it work is you tell the agent you're going to do a thought, you're going to do an action, you're going to receive an observation from the framework, and then you do a thought again, you do an action, you receive an observation, and then it goes through this loop until it gets to the final answer. So as I was saying, most modern frameworks that you're going to see today for these agents, LangGraph, very well known, Crew AI, also very well known. What they call an agent is this React loop. What they add also is memory management. The LLM doesn't remember anything. It's the same LLM as before. But inside the framework, they add a built-in RAG system that retrieves information from a database or a vector database, and it's called memory. So if you use a system like Crew AI, for example, they have a long-term memory, they have short-term memory, and they have entity memory. So it remembers your current conversation, it remembers on the long term your preferences, for example, and it remembers any entities that you talked about, people, places. The way it does that is the model itself is the same. It's just an LLM. It's the Python around it that when you ask a question, it takes your question, sends it to an LLM, says, extract the entities in this question. It extracts the entities, and then it saves those entities to a database. And when you ask a future question, it queries that database, picks up the entities, add them back in the context. So I think that's a very important point to understand is agentic AI agents, it's not something else. It's LLMs used with lots of coding around to make it behave in that way by adding a loop of thought, action, observation, and adding memory and state and retries and guardrails and all these nice things around the model. So user query comes in, there's a high level orchestration happening, it breaks tasks into smaller sub-goals. Then there's a memory in context, so it's going to retrieve knowledge that's necessary, it's going to append it to the prompt. Then the agent itself is a React loop. This action, the framework, the Python, takes that output, does the action, gives back the observation, and asks the LLM to do it again. So it does it. The tool layer is all the tools that you have available, which are added to the context of the agent, so that the agent can pick the tool it needs for different tasks, but it's the Python that executes the tool. So when we say that an LLM does a tool call, the LLM isn't calling anything. It's just generating text that says, I would like to call this tool with this input. You need the Python around, the framework around to take this, call the tool, get the output from the tool, prompt the LLM again. Okay, so this works very well for certain things, okay? And this is where multi-agent systems came in. This was the natural evolution towards multi-agent systems towards the mid-2023, towards the end of 2023. Why multi-agent systems? Because single prompt has its hard limits, as we saw. There's so much you can do with a single prompt. You're not going to get much out of a single prompt from a business practical context. A single agent with tools is good, but it's limited to a single role. You can't mix roles in this particular approach. It has to be a single role. For example, you would say in the prompt of a single agent, you are a helpful assistant that calculates the travel distance, the travel time for any travel. So its role is to calculate the travel time for any travel, not anything else. You can't mix roles. And it has a routine to do that. One routine to do that it's going to loop to do it. Find the first leg, find the second leg, find the third leg, get the total. So these are all separate steps, and it's just going to loop and loop and loop and loop until it gets to the end answer. So the reality for businesses that came very evident towards end of 2023 is that if you want to accomplish anything of moderate complexity, you need multiple prompts, you need multiple agents, and you need multiple roles. So for example, if I want to have a chatbot to talk to my data, lots of people want to do that. This is one of the projects we wanted to do. I want a chatbot to chat with my data. Okay. If I try to do it in one go, meaning when I ask a question, it goes into one prompt, goes to the LLM, gives me the answer. What I can get out of this is going to be extremely limited, very rudimentary. Anything of any moderate complexity is going to fail miserably at doing it. But if I split it, as I was describing earlier, and I split it in two roles, where the first agent is a planner, and basically the prompt would say, you are a planner. Your job is to understand the user request and create a plan. And then the second agent is an executor, which means that its system prompt will say, you are an executor. You're going to receive a plan from the planner, and your job is to execute that plan. And maybe you add another one where you say, you are the analyst. You're going to receive the results from the executor. Your job is to compose a nice answer for the user and respond to the user. By doing that, where you have three separate roles, your quality is going to go through the roof. It's unbelievable how well it would be able to answer your data questions. For example, I had use cases where people want to generate SQL from questions. I want to ask a question, I want it to generate SQL. You do that with a single prompt, you're going to see how quickly it fails. But if you want to generate complex SQL, you can break it down in a planner, parts of the SQL, assembling it. You can make it, 5, 6 agents, and the quality is going to be much, much higher. So each agent has different roles to play, different tasks to complete, different tools to use, and together, these agents can accomplish far more complex tasks with higher quality. So this led to an explosion in agents. Everything you see today, all these applications you see today, even the thinking, reasoning models that you see today, when you ask a question to deep research, for example, or when you use DeepSeek R1, or O1, O3, O4, all these reasoning models. Again, it's the same LLM, it's just that internally it has multiple steps. So Seek, for example, it will have a planning and it will have competing alternatives. I did a test with DeepSeek when I saw that it made 25 parallel calls to get different opinions. And then it assembles all these opinions to figure out the final result. So essentially, since that time, what is going to be happening, why there's been an explosion in capabilities and abilities and so on, is because under the hood, these systems have been broken down into small pieces where each piece does a little job, and together you get incredible quality. You get a sophistication that's much, 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 much higher. So the first design was the sequential design, where you have the user input and you're going to have this agent 1, 2, 3. It's sequential doesn't mean it cannot go back. So it's not a cyclic. It can go back. For example, agent 3 can send something back to agent 2 and can send it back, send it back, and then it can go. So it just means that there is no supervisor agent. There's no agent that decides which agent are going to be called. It's a sequence. It's a predefined sequence, but it can have loopbacks, callbacks, and things like that. So it doesn't have to be in one direction. This design is today where the money is, where all the energy is this. This is what's happening today. These are sequential multi-agent systems. With this design, today, it is understood that you can automate 80% of knowledge work with just this design. So it's an extremely powerful design where you can do pretty much anything. Take a call center employee. Receive the call, determine what the request is. That's agent number 1. If the request is sales, go to this agent. This agent will determine which product are we talking about. Agent number 2. Then agent number 3 is going to decide how to discuss that product. Agent number 4, you see what I mean? So the breaking down of the task, and you get this. The other model, which is much more complex, is not very well used yet because it's a bit harder to control, is a hierarchical model where you have one central agent that will decide on what's going on. So complex sales agents or customer service agents will be like that, because depending on the request, there's so much variability, you can't predefine a sequence. You have to let this particular LLM understand what it is we're trying to do here, and then based on that, it's going to invoke different agents based on what it's trying to do. So that's the hierarchical model. We tried it. We're not using any of it yet. There's not that many people who are using it. Most are using a controlled sort of workflow where I need this one first, this one second, this one first. The most complex systems that I have today like this have something like 40 different agents to do incredibly detailed work. And you can achieve very high levels of quality with this because you can have reviewers. You can do this one, do a task, and this one is responsible for reviewing this task. So if this one hallucinated, this one is going to catch it and is going to correct it. So lots of great quality. There are many, many frameworks to do this. LangChain, LangGraph, LangFlow, AutoGen, Lemma Index, Semantic Kernel, PromptFlow. One of my favorites is CrewAI. It's incredibly simple to get started, incredibly powerful. Everything is there out of the box. And the way the framework is done is very useful. My point with the framework is that the incredible thing about all this is that 90% of the code is boilerplate, meaning it's always the same thing. So there's absolutely no point in programming any of this yourself. I did program this myself from scratch in the beginning. After that, I quickly noticed that it's the same thing. It's the same thing again and again. A React loop is the same Python code every single time. You prompt, you get the output, you parse it, you call a tool, you send it back, you prompt again. It's the same thing. Memory is the same thing. You do a semantic request, you do a semantic search from the vector database, you get the result, you add it to the prompt. So all of these things is a boilerplate. So you're much better off using a framework. It doesn't make any sense to do this manually. So you're much better off picking the framework that you like and using a framework. Very popular, LangGraph. You can do very good workflows with that, but many of them are available. So where we are today is that AI, agentic AI, is a known paradigm. System composed of multiple roles, tools, memory, planning. Companies understand it. Those who have started before, they understand it. It is not like a mysterious thing, and most companies who started at that time are moving beyond the experiments towards production grade systems. So right now it's all about production and scaling. And the reason is that those systems work, they're extremely effective, they're easy to design, and they're very well understood. So what companies are doing is looking at what workflow do I have today where I have a human bottleneck, or that's a very lengthy workflow that's taking a lot of time, that's costing a lot of money. How could I take this workflow, chop it up in little pieces, and I'm going to create an agentic workflow where all these human tasks, think of, again, the assistant answering emails, right? The task of answering emails can be broken down. First, you receive the email and you understand what it is, agent one. And depending on that, you route to different places. If it's a complaint, you send it to this other agent. If it's a request for a refund, you send it to this other agent. And then that other agent will clarify something else. And then it will send it to another agent, which will clarify something else. And then the job is finished after that. You can see everything that's happening along the way for audit and observability and so on. And you can essentially automate. I cannot think of a single knowledge work that cannot be automated to at least 80% using this approach. So that's where we are today. We're scaling those systems. So essentially, every use case today is agentic, because what are you going to do with a single prompt? There's nothing you can really do with a single prompt. Even a chatbot, if you have a single prompt in your chatbot, you're going to get hallucinations. How are you going to catch those hallucinations? And by having just 2 agents in this chatbot, you're going to increase your quality dramatically. So anything of business consequence is essentially agentic, which is not a new technology. It is just an effective way of using LLMs to split things in multiple steps. Okay, I'm going to speed it up to leave some time for questions. So one more thing. Things are still evolving. There's something new now that's coming in, which is OpenClaw, which you probably heard, which was called Moltbot before, and then it was called CloudBot before. What lots of people not in the industry are missing is that this is really the first credible prototype of a digital employee. This is something that runs, and again, it's not something new. It's a design pattern. It's the same LLM inside, but in a different design. This is something that you can install on your own machine. You can configure to use whatever LLM you want, and you can connect it to any communication app that you want. Telegram, WhatsApp, Teams, Google Meet. And you can give it skills, which are just tools, which are just Python functions, which many people are building lots of skills. So you can ask it, hey, can you book a reservation for me? And it's going to understand you. It's local. It has memory. It remembers what you're asking. Today it doesn't work yet, It has huge security flaws. It's totally unsafe. Don't use that at work. But for those involved in the industry, you can clearly see this is the beginning of the digital employee. It's something sitting at the other hand of your teams. If you are a team lead, you have teams. How do you ask employees stuff? Let's say you have remote employees in India. How do you ask them? You send them a message on Teams. Hey, can you do this? It's the same thing, but in this case, it's a multi-agent system sitting on your hardware that's has all the skills to do all these jobs. So OpenAI is going there, Claude is going there. For computer programming, I can tell you that and this isn't even yet implemented, and it's not going to be implemented soon, but in my team, and me personally, we're not even programming anymore. We just ask, give the specs, and then there's an agentic system that's going to take the specs, break it down into a plan, send it to an architect agent, send it to a developer agent, send it to a reviewer agent, send it to a QA agent, and then your software is written, right? Last year, I've written very big, very complex applications without writing any code myself at all, just using the Replit agent. So this is coming next. And I suspect it's not going to take that long for it to come there. But there's still a big gap. There's a big gap between, this is an image from Gartner that I found was useful. There's a big gap between what the AI can do and what people are actually using it for. Most companies are really not there. The big gap comes a lot from the fact that it's not just the technical side, which people don't know. They have to learn, they have to experiment. A lot of programs don't teach it. I was interviewing someone from Mila the other day. Person had no idea about agentic AI. They had never done any of it. They had no knowledge of it. They knew a lot about traditional machine learning, which we're not doing at the moment, but they had no idea about this. So there's a big gap in terms of knowledge, and there's a big gap with people. People need to be trained. There's change management, so it's going to take some time. So just to conclude, this moved pretty fast from 2022 to today with agentic workflows. The focus really has shifted from a static sort of I'm assuming, to multi-step automation, which you get much higher quality and you can accomplish things that are much more complex. And companies are building teams. If you look at the recruitment around AI, it has increased dramatically. Seemingly everyone is looking for a head of AI, a head of AI lab, head of AI enablement. New startups are coming for AI adoption. I was talking to someone the other day. There's a big business in AI adoption. The adoption is still very low. People don't know how to use the tools. So there's a high level of recruitment in this field. So my final recommendation would be, you're much better off experimenting now as much as you can to learn before the market forces you to. As a company, the market will force you to. Your competitors are gonna do it. As an employee, the sort of cliche sentence that everybody keeps repeating, AI is not going to replace people, but people using AI is going to replace people. It is true. It is very, very, very true. Especially if you're in development and if you're in engineering, you absolutely must learn these things. But in reality, it's every field out there. It will take some time, but it is definitely coming for all of us. So that's it. I'll stop there. Any questions? Any interrogations? Gray areas?
Well, thank you so much, Paco. And I want to highlight the fact that one of the reasons I brought in Paco is he talks with experience. He's been doing this for many years. We draw on his expertise. He helps us actually with the program. He helps us. He teaches also with us when he has the time, not always. And I would say the presentation he did today is something you will not find anywhere. And I'm not saying this just because it's Paco and he's here in the room, but in general, very few people will give you this start to end view, where we were, how we got here, or, what's happening, the reality, the real issues, etc. Like, this is very clear. This is, there's a lot of words that were kind of thrown out that we don't all know. And, like we talked about, context windows, tokens, latency, semantic space. There's a lot of other words. I started typing them as we were going through. But that's the cool thing is now you can go back and you have the presentation and you have this video. Please, this doesn't leave the room. Like, this is really not made for professional sharing, etc. But this is for you. And you can go over and go back and forward until the point that you feel more comfortable with the terminology. And you can use generative AI, the LLMs, to help you understand these much better. Like, I spend a lot of time learning. So what you do is you ask questions, but you need to have a base to start off with. I'm going to leave you for questions. We had Natalia threw her first question out there, which is, OpenClaw, what's the origin? Is it North American, European, Chinese?
OpenClaw, it's a developer from Australia, I believe. Started as Austria. It's an Austrian developer called Peter Steinberger. He created it in a few months ago, and it took on fire. It went to over 100,000 GitHub stars and 2 million visitors in a single week. It's very impressive when you install it. And by the way, I'm saying it's not secure, so be careful, because it's an AI on your machine that can do a lot of stuff. So it can hallucinate and do some things that you don't necessarily want. But once you install it, it says, hey, hi, how do you want to call me? What kind of vibe do you want? And you say, okay, I'm going to call you Alfred. And I respond, okay, great, thank you, I'm Alfred. So what can I do for you? Can I, filter your emails? Can I do your tasks? You want me to book some hotels for you? And it has hundreds and thousands of skills. So you can literally take your Telegram or your WhatsApp and say, hey, Alfred, can you book a hotel for me for tomorrow? It's going to go and do it. Oh, can you remind me of this and that? You can connect it to your emails. You're going to receive an email. It's going to see who's sending you what, and it's going to tell you, hey, this person sent you an email. You have an appointment next week. I'm going to add it to your calendar. I'm going to put it in your to-dos. So it really feels like something else. So that's why it took on such popularity. Everyone is learning about the security issues. Yes, it's not there yet, but give it a minute. It's been there for 2 months, so it still has a lot of time to evolve. So it shows you how fast these things are going. But the point that some people are missing, that are not being missed by others, is that in the future, when people want to have digital employees, it's going to be based on these kinds of design. These are the beginning of digital employees that you ask to do tasks from your teams or your messaging system. So not Chinese, no, Austrian.
Any other questions? Nketa, do you want to... Okay, good question. You said that people do not train about agentic AI at school for now. So is there any training or certification I can do to master, or at least be comfortable with agentic AI?
Yeah. So the training that I really like, and I did almost all of it in 2024, is deeplearning.ai, with Andrew N.
Engie. Yeah.
Ng. So deeplearning.ai, amazing. It's free. Everything is there, everything. So, what I did when I was starting in this field, I really saw the potential personally, potential for my own career, potential for the organization. So I started a regimen of spending half an hour a day on weekdays to do a course, small video courses, 10 minutes. A whole course is maybe an hour. So just by half an hour a day. And I can tell you that at the end of 2024, I printed my report and it told me I was top 1% of learners in 2024. So it just goes to show, you just do half an hour a day. That's nothing. That's absolutely nothing. But if you just do half an hour a day in a platform like that, and there's many others, but that's the one I spend the most time on, you will have, your knowledge of AI will be through the roof very, very, very quickly. You don't have to go crazy. You don't have to do too much. Just a little bit of time on a daily basis on a platform like that is very good. So I recommend that, deeplearning.ai.
I'm going to follow up with a question, even, I would like to leave it for other people, but I'll follow up with a question which is related. Python knowledge.
Yeah.
What's your opinion on that? That's because you mentioned Python multiple times. Everything is done in Python. We use Python, the wrapper. Yes, we do have boilerplate code, but Python is mentioned a lot in you mentioned a lot. So
yeah.
your view on that, because this is the first course in a series for the students, as you know. So I'm incredibly happy you came at this point, because this sets the agenda, if you want, for the next little while.
Yeah. So, if you would have asked me a couple of months ago, I would say, okay, to build these things, you need the Python skills. The thing is, there is a shift happening at the moment. Like I said, in the last 6 months, I'm not even writing code anymore. I wrote code my whole life. In the last 6 months, yesterday, I had something to create. I wanted to create evaluation scripts that would run eval and compare two different Neo4j databases using Cypher queries. It's a different type of queries. Neo4j is a graph database. And I wanted a routine that would calculate all the differences so that when we refresh database B, we can check against database A and we can make sure that it all looks good. Same numbers, same counts, we're good, we didn't break anything. Normally, I would have opened up my VS Code and start typing code and maybe go to Stack Overflow and find things and so on. I described it to Opus 4.5, and 15 minutes later, I was done. It created all the code. I gave it my schema. I said, here's my schema. Why don't you create me like a dozen queries to get me started on this eval? So not only did it write the whole Python code, it wrote all the Cypher queries. So I don't know how much you need to know how to actually program in a very near future. What would probably be more useful is, that's the tricky part, is if you don't have the development experience, you don't really know how to ask the LLM, but you don't need the coding anymore. So how do you get that development experience without the coding? In other words, I'm able to use LLMs in that way because I have this experience. Now, if you don't have the experience, how do you use the LLMs in that way, right? It's a little situation where maybe, it's a kind of a catch 22. I think learning maybe design concepts, architectural concepts may be more useful. Do you need to know how to write Python anymore? As of right now, maybe not, and maybe it will decrease over time, but it's not going to happen right away. It will take a little bit of time. We're still not using fully autonomous coding systems, so maybe what would be safe, okay, I mean, this is a very long answer, but maybe what would be safe is just learning the basis to be able to understand what's going on, to be able to ask the LLM for it. Maybe that would be enough to have a basic level of knowledge of it. Yeah.
I tend to agree with that, in a sense that if you don't know anything about code, you can't ask the right questions. It's the same about math. It's the same about linear algebra. It's the same about anything. Not having domain knowledge makes it incredibly difficult to ask questions, because the questions you would ask are too general, are too biased in a sense where you don't know, and when you don't get the answer you want, you don't know where to go further to get that information. So I don't expect, and I don't, want people from my, I'm talking now as an instructor, as the person teaching this material. I don't expect people to become coders the way they did in the past, but they understanding code, building code, being comfortable with the ideas around code makes it a lot easier to do it. Like part of the success that you have, I'm not gonna, sometimes people ask me, how do you get the LLM to do that? Or how do you get it? It's the experience of knowing how to ask questions, but you have to know what to ask. And that the most difficult part is when you're an outsider to a business is asking the right questions. Okay, so there's other questions. There's Maria that was asking a question. Actually, there's a lot of questions here. The first one, the easy one is, do you have a YouTube channel or is it just a blog?
Just a blog.
Just a blog. Okay, yeah. But you have been on video. I found something on the internet.
Oh yes, these are very, very old videos from a course. But there's an interesting question there about multi-agent system. Is it the final landing spot?
Yeah.
That's a very interesting question, because companies are coming up with large language models, or their reasoning models that can do a lot now. That can do much more. But from a business perspective, we may stop at the current multi-agent systems. We may very well stop there. The reason is that if I'm a business, I have a big concern about responsible AI and AI governance. I need my systems to be observable, to be transparent. I need to have audit logs. Otherwise, I cannot release them in production. I can't be in a bank and I have a system that's doing stuff and we don't know what it's doing. So I need to know what it's doing. If I give a task that is too big to an AI because it's able to handle it, the problem is, even if it's able to do a good job, I lose the control, I lose the observability, I don't know what's happening inside that agent. It's just doing stuff and then I get the output. So even if the output is good, the problem of me not knowing what's happening is very problematic. So a lot of our use cases are still running on older models, because from a business perspective, you do want to have the control. You want to know the steps. You want to be able to audit. You want to be able to see what happened here, what happened over there. And you want to be able to keep the control. You don't want any black boxes. Otherwise, it's not responsible. So it is quite possible that from a business implementation perspective, a lot of businesses for now are just going to stop there. And you're not going to go to anything fancier, just because of that necessity to have the control and to have the observability.
Yeah. And what we have today, and if you work for a company, you will find that in general, most companies, when you talk about general deployments, we're not talking about groups like PACOs, which are very specialized. In general, you don't have access to latest technologies. You're using models that are closed or older. Let's ask one more question, and I think we'll take it from there. There's Gabrielle who's asking, you think AI will get good enough to work effectively on large, messy legacy code bases? I feel like it works better when starting from scratch. And Greta is asking how really AI is used in engineering. AI is stuck on some mathematical problem like linear programming. I tried it on ChatGPT, but it is not good. Or is my problem is correct prompting? Both questions are excellent. And, if you have the time, Paco, please answer them. If not,
we can finish. We can finish with that. So, does AI good enough to work effectively on a large messy code base? The recent ones are. The recent ones from Claude are, and they're certainly going to get there because they're really breaking it in small pieces. Each of the pieces are much smarter. If you look at Opus 4.6, these are super smart models. So I mean, it depends how legacy it is and how big it is, and how messy it is, I imagine. But I think maybe with a little bit of difficulty, but I think yes, it is possible today with the latest implementations, especially if you look on the side of Anthropic, which are very advanced on this front, but OpenAI as well. So definitely yes, but you'd have to try with your own code base. There's also ways of doing it. You can ask it to document it part by part. You can yourself also split the problem that you're asking and go gradually towards the solution instead of saying reorganize my code base and go. So you can start by asking to document it and then ask it to review the documentation and ask it to make a plan for making it less messy. And you can gradually bring it to a certain point. So I hope that answers your question. Then last one, and we'll end there on my front. How really AI is using in engineering? AI is talking so much about So it's not ChatGPT that's used in engineering. There's platforms, for example, like Replit, where you can create I've created an entire application just asking it. And they have an agent system that splits each request into an architect, a planner, an executor that changes the code, a reviewer, right? They split it in many steps. If you would code or OpenAI's implementation, just to give you an idea, when you say AI in engineering, right now, since January, we are going all in on AI adoption for engineering. Everybody in engineering understand that the old days are gone. Now is a new era where engineering will be extremely heavily AI oriented. Everyone is encouraged to install Copilot agent mode on their VS Code, for example. And that's not even far enough in my view, because as of today, there's already platforms where you don't even need to see the code yourself. You can just ask and it will give you the code and you can see it on the left side, right? You can see it in the platform I mentioned, Replit. It's like a ChatGPT, but you ask for an application. Try it yourself, you'll see that. It will create the application very well. Just by you just asking, it will create any application that you ask it to do. Very complex applications. So it's not perfect yet, but I started trying it maybe in July of last year, and from July to November, it was already much better than it was in the beginning. So AI in engineering is not only happening, it has already happened, and it is probably one of the heaviest, most reliable most important use cases you can think of. If someone's job is to take specs and to write code, you can be fairly certain that it's an AI that's going to do that job in a very near future in most companies. So this is definitely happening, and it's happening fast. It's called Replit.
Yep, Replit. I'll put it down. I'll write it for you.
Like this. Yes, Replit like this. And you sign up. It can get expensive, so be careful. But you sign up and then you ask. You say, "I want this company," and it will build it for you. I've built a very big application with that. Actually, if you go to my blog, it is built using Replit. And the content management system in the back of this is built using Replit entirely. So I'm not using WordPress. I'm using an entire content management system created with Replit. So something to. There are many other options, and I think Anthropic is probably one of the most advanced one. GitHub Copilot right now is what we have at work that's starting to write code instead of us. So in engineering, it's definitely happening at the moment. All right. Well, thank you.
Thank you
For the invite. Thank you very much.
So definitely, this was amazing. Thank you so much, Paco. Amazing. Again, I probably said it enough times, but really definitely worth it. What we will do is I think everyone is overloaded right now. Their brain is going into overload mode. So we'll take a 10-minute break till 7:25, and we'll take it from here. Thank you so much, Paco.
Thank you, everyone.
So I think everyone feels overloaded.